Welcome. Let's look at an example of non-linear regression. So we are looking at a data set which is about school marks that the students have got, and we are trying to compare that against a number of input fields such as the household expenditure, uh, the income of the house, the community, location, and a couple of things here. So let's have a quick look at the file. So as you can see, you can have the student to teacher ratio, number of students, whether lunch is provided or not, a couple of information. For the sake of this example, we are interested in two specific columns: the input column income and target variable score. Now, if I do the describe command, for instance, I get a range of values of the income field. So looks like it varies from about 5.355 all the way to 55 in some unit of measure, and then the score itself varies from about 605 to about 706. So what we're trying to do here is to build a regression model with the score as the target variable and income as the input variable. Now let's do a quick plot just to see if there is any kind of correlation between the two. So I'm going to plot income on the x-axis and score on the y-axis. Now, as you can see, uh, the relationship shows probably a positive correlation, because if the income increases on the x-axis, the score does increase. But it seems to take some kind of a curvature here. So essentially, it's not a linear relationship; it is a non-linear relationship. And let's just try to fit a simple regression model and see how it looks like. So I'm going to prepare my x and y data set. Let's build that. Let's build our income. Let's fit the model, and let's look at the R square. So the R square, which has one variable, is around 50.7, which is a very decent R square when you look at it. With just one variable, we are able to explain a fair amount of variance in your target variable. But you do know the issue is that there is a non-linear relationship. So if you were to plot those values, the regression line along with the original plot, this is how it looks like. So what I've done is I've taken the income and I predicted what would be the score based on our regression model, and I kind of plotted that on the screen. So as you can see, the red line is the one which is the regression line, and it is trying to predict your income versus score. Now, as the income goes higher and higher, obviously the predicted value is deviating quite away from your actual reality here. So, if you just want to quickly do a screen sketch, and as you can see, instead of plotting it this way, there is an angle because it is trying to force fit all the data points. And as you go towards this region, you can see that the actual and predicted is moving away from each other. So it did do its job, but then it is not a very effective job. So the error is going to be higher, and so your R square has ended up with about 0.50 or something. Now what we are going to try and do is, why don't we look at the square of the income rather than just the income field itself, and see if I use that variable along with the original income field, does it improve anything? So what I'm doing here is I'm creating a new column called income square, and essentially I'm squaring the income column, storing it in this variable, and now I'm creating my input variables with two variables here. Let me build the model and let me look at the R square. So you can see that the R square did improve from about 50 to about 55. So we have a model which seems to be performing much better than your previous model. Of course, taking into consideration there are two separate fields, one is income and income square. Now, if you care to look at the coefficients here, say something like this, and if I look at the intercept, say something like this. So what it means essentially is that your score is equal to 607 plus 3.85 into income minus 0.042 into income square. Right? Let's come out with an equation, and it definitely is an improved R square. Let's also try to quickly plot it and see how it looks like. So I've used another color as well. So I've created the original plot, which is in the blue color. The red line that you see is the prediction based on the first model. As you can see, they have moved further away. And if I want to now look at the third model, which is represented by the green line here, it closely follows the data more than it did for the previous model here. So this model is definitely an improvement, and it does seem to trace the data a lot better than the previous models. Now, this is something that you learn from experimentation. Now, I have taken square of the income. There are other options available for you where you might probably transform the data using a log function, or there could be other scaling functions that you can do to perform. There's a bit of trial and error that you will have to in order to get a handle on how to transform this data. Now, transforming the data is quite simple. You just create a new column and you transform your existing column and then save it there. And you just do that with any other regression. So essentially, all you have to just include those two new columns, like the way that you will use existing columns, and just deal with it. As simple as that. Thank you.